Okay, so this is technically video 3. We're picking up right where we left off on the other video. Listen to this. We already know that a square root is the power of 1/2, right? The square root is really the power of 1/2. You could rewrite it, which is why it's easy to simplify the square root of x to the 8th. The answer is x to the 4th. It's kind of like dividing the inside power by 2. So because the square root is the power of 1/2, it's kind of like dividing the inside power by 2. You want an even number in there. Even if you don't have an even number in there, you rewrite it so you could have an even power in there, okay? But there's more than just square roots, as previously mentioned. There's third roots, there's fourth roots, fifth roots, you name it. There's all kinds of roots. So let's jump up here and understand these facts. We already know square root's the power of 1/2, which is kind of like dividing the inside power by 2. A third root is the power of 1/3. It's kind of like dividing the inside power by 3. A fourth root is the power of 1/4, which is kind of like dividing the inside power by 4. Okay? So let's practice understanding that. Number one, a lot of people get freaked out here. 27 to the 1/3, that's really just saying what is the third root of 27. Okay, so you could rewrite this as the third root of 27 if you're more comfortable with radicals, right? So what is the third root of 27? 3. Now, if you say 9, think about it. What's 9 times 9 times 9? That's definitely not 27, right? Okay, so what times itself? 3 times gives you 27? The answer is 3. 3 times 3 times 3. So the third root of 27 is 3, okay? So you could switch your rational exponent to radical form. Okay, let's look at this other one. So right here, what could we do? Any ideas?
We divide by 4.
Divide what by 4 though?
Oh, no. Divide the 4.
Okay, so what is the 1/4 power really? The 1/4 power is really the fourth root. Yay?
Yeah, so you divide it by 4.
Guys, it's up here. Look.
Divided by 4.
The 1/4 power is really the fourth root. So, ladies and gentlemen, I think we're pretty comfortable with roots. So, if you're comfortable with roots, you might as well rewrite that as the fourth root. So, let's do that. Let's rewrite it as the fourth root of 1 over 81. And I think now, since we're comfortable simplifying roots, what could we do now with that fourth root?
You could.
When you have a fraction inside a root, what are you supposed to do?
Split it.
You're supposed to split it. So when you split it, you have the fourth root of 1 over the fourth root of 81.
81.
So,
It's the same, and then you have to
well, let's think about it. What is the fourth root of 1? What times itself 4 times gives you 1? 1. So your answer has a 1 on top. How about the fourth root of 81? Is there something times itself 4 times 3? Right? 3 times 3 is 9, times 3 is 27, and then 27 times 3, it's actually 81. So this answer is simply 1/3. Cool? There's many roads to the same place. I could simplify this many different ways. I could even mess with 81, change it to a 9 squared. I could move it up and change it to a 9 to the negative 2 power. I could do all kinds of tricks with math. But since we just got done with radicals, I want to keep it as the fourth root. I want to keep it as a radical. Number 3, 54 to the 1/3 power. What's that really saying? It's saying the third root of 54. So what times itself 3 times gives you 54? I don't know. If I go 2 times 2 times 2, what do I get? 8. If I go 3 times 3 times 3, what do I get? 27. If I go 4 times 4 times 4, what do I get? 60. Wait a minute. 54 is not even in there, right? Now,
27.
but 27, I could rewrite 54 to become 27 times 2. So let's do that. Let's go 27 times 2. That way when we split the third root, we could actually do the first one here. The third root of 27, what is that? 3. And how about that third root of 2? Stays the same. So that's your answer for number 3. It's just a question of getting used to it and practicing. Now, ladies and gentlemen, at this moment, I know we do not have these numbers, I would like you to flip your paper over and copy down these questions as we go. Because you guys got an old version of the notes. I have a newer version of the notes. So copy down these two questions, number 4 and number 5. The 6th root of x to the 12th, the 5th root of x to the 35th.
What's the highest that the root can go to?
I mean, it could be infinity, right? But I mean, yeah, you could have the 13th root. You could have the 27th root. Who knows? But the fact of the matter is that we know that the 6th root can be rewritten as the power of what?
1 over 6.
1 over 6. And the power of 1 over 6 is kind of like dividing the inside exponent by 6. So what's the answer here to number 4?
2.
X to the second. Crazy, right? Again, since I'm doing the recording here, let me explain. The sixth root could be rewritten as the power of 1 over 6. And on the inside, we have the x to the 12th. So what we really have is a power to a power, multiply them. 12 times 1/6, that really becomes 12 over 6. And 12 over 6 is really just 12 divided by 6. So the answer is, if I show my work, 12 over 6, the answer is x squared. Now you don't have to show your work. You just need to know that the 6th root, it's really the power of 1/6, so it's kind of like dividing this by 6. Cool? How about number 5? What's the answer to number 5?
7.
X to the power of 7. Because this is really saying the 5th root is kind of like dividing 35 by 5, which is really 7. So the answer is x to the 7th. So here's my answer, x to the 7th. If I want to explain to somebody that's barely learning the stuff how I got x to the 7th, I would say, well, the fifth root right here of anything is really the power of 1/5. And on the inside I have x to the 35. So when I multiply 35 times 1/5, I want to have x to the 35 divided by 5. And 35 divided by 5 takes me back to that x over 7. Like I said, on the quiz, you don't have to, or the test, you don't have to show this work. You just need to know that the 5th root is kind of like dividing that by 5. The 6th root is kind of like dividing that by 6. Are you with me so far? Yes. All right. Copy this one down now, 6 and 7. As you can see, it's getting a little more interesting because 13 is not divisible by 4, is it? Okay. So since I have the 4th root, I want this to be divisible by 4. But it's not. So the question is, could I rewrite this with multiplication to get something that's divisible by 4? Yeah. I want to rewrite that x to the 13th as what? X to the 12th times x to the 1. But you don't even need the 1. And I hope everybody's keeping up with me right here, since this is a new topic. Okay. Now we're going to split the 4th root to each of those. And of course, this the first one works out beautifully. What's the answer there?
3.
X to the 3rd, because the 4th root is kind of like dividing this by 4, so that becomes 3, x to the 3rd, no more root. And this 4th root of x to the 1, you can't do it, so you're just going to leave it. The 4th root of x to the 1, or just x. So that's your answer, x to the 3rd, 4th root of x. X to the 3rd, 4th root of x. How about number 7? So 7, you have the 7th root. So it'd be nice if this were divisible by 7, but 19 is not divisible by 7. What would be divisible by 7? 14 would be divisible by 7. So we would like a 14 right here. So let's rewrite with multiplication to get that power of 14. So I'm going to change that x to the 19th. I'm going to change the x to the 14th times x to the 5th. I need 5 more to get all the way to 19. 14 and 5 is a total of 19. And now I could split my root, my 7th root, I should be saying, to both of those. That way now I could actually do 14 divided by 7. What do I get? X to the 2nd. And the 7th root of x to the 5th, you can't do it. And you can't break it down. That's it. So you're just going to leave it, the 7th root of x to the 5th. All right, so those were fun. but these are more for like a party. Oh yeah. The fourth root of that craziness. Copy that down, please. And this is technically number 8 right here. The fourth root of that stuff right there. Excellent. Somebody already said it. It's easy because we're going to break it up, right? You're going to split that fourth root, the fourth root of 32, the fourth root of x to the 8th, the fourth root of y to the 12th, the fourth root of z to the 2nd. Now, since we're dealing with the fourth root, we're thinking what times itself 4 times gives us 32? Let's think about that. 2 times 2 times 2 times 2. What does that give us? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That didn't give us 32. So if I tried 3 times 3 is 9, times 3 is 27. Times 3 is going to be too big. So we are going to have to use the 2, right? Check it out. 2 times 2 times 2 times 2. That gives us 16. 16 times 2 is 32. So I'm going to rewrite the 32 as 16 times 2. That way when I split the fourth root, I will be able to do the fourth root of 16. What is the fourth root of 16?
Wait.
7.
2.
Wow. 4, 7, 2, 9, 35, 84.
7.
None of the above. The answer is 2, ladies and gentlemen. Okay, what times itself 4 times gives you 16? The answer is 2, right? So you have a 2 right there, and the fourth root of 2 is going to stay. Okay. Now what about this fourth root of 8? What does that become? Fourth root of 8.
No, it becomes. Wait, it's
X to the 2nd power. Remember, a fourth root is kind of like saying divide this by 4. 8 divided by 4 is 2. You were right. X to the 2nd power. Actually, write it down here. X to the 2nd. Sorry.
We don't put the 4.
There's no longer a fourth root. Remember, a fourth root. Okay, you know what? Just for kicks here, let me show my work here. It's x to the 8th, and instead of the fourth root, you put the 1/4 power, and that's why 8 times 1/4 is like saying 8 divided by 4, and that's how we get the 2. No more root. How about the other one? The fourth root of y to the 12th. Y to the 3rd. Excellent. Y to the 3rd. And this last one, the fourth root of z to the 2nd. Could you do that? No. Not really. You could actually simplify it, but we're not going to do that right now. We're just going to bring it down the way it is. So we have the fourth root of z to the 2nd. Okay, so now we have our answer. Let's take the nice terms that don't have radicals, put them out in the front. So I have the 2, the x to the 2nd, and the y to the 3rd. 2, x to the 2nd, y to the 3rd. And then we have our fourth root of 2 and our fourth root of z squared. So we're going to put both of those fourth roots together underneath one radical, a 2 and a z squared. All right, so I think we're good. Oh no, we still need one more. All right. Seriously, guys, this is fun stuff. What you got to do, if you ever go to a party or something, turn on the lights, turn off the music, pull out this problem right here, tell everybody to gather around. Explain it to them. Instant popularity, okay? You're going to be a stud. All right. So let's split up this third root, the third root of 16. Actually, before I explain it, let's see if somebody could get the right answer. Go for it. So let's split it all up. We also have the third root of x to the 12th. We have the third root of y to the 9th. And we have the third root of z to the 17th. So we have 4 problems that we're doing. Now, we want a perfect cube number, right? So 2 times 2 times 2, that's 8. 3 times 3 times 3 is 27. You're already too big on 27, so you have to use 8 right here instead of 16. So let's rewrite 16 with multiplication to get a perfect square number 8. So we're going to rewrite it as 8 times 2. That way when you split the third root to both of those, this first one becomes what? 2. So the third root of 8 is 2. And then you have the third root of 2 left over. And that's okay. Then we move on to the next one. The third root of a variable to a certain power, it's really the 1/3 power of this. So it's really asking you, could you divide this number by 3? Yes, so what's the answer? X to the 4th. Of course, the explanation is that you could rewrite the third root as the 1/3 power, and if you have the x to the 12th in there, you multiply 12 times 1/3, which is dividing by 3. So you end up with x to the 4th. Okay, the next one, what's the answer? Y to the 3rd. Excellent. The last one is the interesting one, because 17 is not divisible by 3. So you want to rewrite it with multiplication to get something that's divisible by 3. 15, right? So let's go z to the 15th power times z to the what? Second. That's what you need in order to get 15 and 2 giving you that 17 up there. So you need the 15 and the 2 to give you that 17. So let's split the third root now. The third root to the 15 and the third root to the z squared. So the third root of z to the 15th, what's that? Z to the 5th. And the third root of z to the 2nd is the third root of z to the 2nd. That's your long, nasty looking answer. All you need to do is clean it up, rearrange things. Let's put the outside terms first. The 2 out there. The x to the 4th right next to the 2. The y to the 3rd right there. And the z to the 5th right there. And finally, at the end, we're going to take the third root of 2, the radical, and put them both together under one radical value, 2z squared. That's your final answer to that one. I'm telling you guys, take it to a party. Instant popularity. So we're going to continue. We're going to end this video here. We're going to continue on the next video doing this last final part of the notes.